So let's quickly review the distance time graphs and the speed time graphs. Let's start with the distance time graphs. For a distance time graph, you're going to have distance on the y-axis, which is, let's say, going to be in meters, and time on the x-axis, which is, let's say, going to be in seconds. Let's quickly draw a distance time graph for you as well. And let's call these regions OA, B, and C. So the first thing to note is that the gradient of a distance time graph, it gives you speed, okay? Because for the gradient, we find the change, for the gradient, we find the change in y over the change in x. And now because on the y-axis, you have distance, and on the x-axis, you have time. So distance over time is speed. This means that for a distance time graph, the gradient gives you the speed, all right? Okay, let's talk about the different shapes that you can have in a distance time graph. So for example, the first shape, the first thing that you could have is a flat line, like in the region A and B. A flat line, it tells you, like in the region A and B, it tells you that the distance is not changing. So for example, if the distance is 60 at this point, then over the period of A till B, the distance is not changing, it's the same 60, all right? So this means that no distance is covered, which means that the car is stationary. So this basically means that uh, the speed is 0. Next, we can have straight lines, which maybe are going up. So a straight line, it tells you that the speed, that the gradient, it's constant, so the speed is constant. Now you could either have, there could be different steepness of a straight line. So for example, as a region OA, you can see that the line is more steep. So we say that the speed is large. If the steepness is less, as per the region BC, then the steepness is less, and the speed is also going to be small. So if the straight line is more steep, then it corresponds to large speed. And if it's less steep, then it means that the speed is going to be small. Okay. What if the distance time graph is not a straight line? It's a curve. Maybe it's something like this, going up like this, not a straight line. So for the region CD, we have a curve, and that means that the speed is not constant now, it's changing. So for a curve like CD, we say that the speed is changing. Let's talk about the speed time graphs now. For the speed time graphs, we are going to have on y-axis where we have speed, which could be in meters per second. And on x-axis, again, you're going to have time. The graph could be of a shape like this. Now this time, the gradient it's again the change in y over change in x. So it's going to give you the change in speed per unit time. And that is acceleration. So the gradient of a speed time graph, it gives you the acceleration of the body. Again, we can have different regions. We can divide this in O, A, B, and C. For a flat line like AB, we know that the gradient is 0, which means that the acceleration is 0. And if the acceleration is 0, it means that there is no change in speed, which means that the speed is constant. If you have a straight line, then it means that the gradient is constant, which means that acceleration is constant. Now, there could be different kinds of straight lines. For example, the straight line, it could be uphill, which means that it's going up, and like the line OA, it's going up. So an uphill line means that the acceleration is positive. So a positive acceleration means that the speed it's increasing. As you go from O to A, the speed is increasing. If the straight line is downhill, like the line BC, so it's coming downhill, we could say that the acceleration is negative, and negative acceleration is called deceleration. So deceleration means that as you go from B to C, the speed is decreasing. For example, if the speed was 80 meters per second here, at B. As you go to C, the speed it becomes 0. So from 80 meters per second at B, we went to 0 meters per second at C. So we're going downhill, it's deceleration, and the speed is decreased. Now again, you could look at the steepness of the straight line as well. If the line is very steep, like the line OA, then the acceleration or deceleration, whatever it is going to be large. If the line is less steep, like the line BC, then the acceleration or the deceleration is going to be small. If we have a less steep line, like OA, OA is the more steep one. So if you have a less steep line like BC, then the acceleration or deceleration it's going to be small. And if you have a more steep line, like the line OA, then the acceleration or deceleration, whatever it is, it's going to be large. There's one last thing that a speed time graph could tell you, and that's the distance traveled by the object. So let's make a speed time graph again. So let's say that you have this speed time graph. Speed is in meters per second. Time is in seconds. This is 20, 40, 60, and 80. Now for the speed time graph, the area under the graph, which means this area, which is under the graph, this whole area is actually very important because it could tell you the distance that is traveled by this object. So this whole area under the curve tells you the distance that is traveled by this object while it was traveling at this speed for this much time. There are two ways that you could find the area under this graph. Either you could think of this graph as a trapezium, the shaded region as a trapezium, with the sides being this side is 80, and this side, it goes from 30 to 80, so that's 50. And the height of the trapezium is 40, because this is the height. So either you could think of this as the trapezium, or if that doesn't, that's not your kind of thing, you could just draw a dotted line here, find the area of this triangle A, find the area of this triangle B, rectangle B, and add those two together. So I'm going to find the area of triangle A. For the triangle A, the base, that is 30. It's going to be 1/2 times base into height. The base is 30 and the height is the same as this, which is 40. So altogether, you get 2 and here you get a 20, so you get a 600. So 600 meters from the area of triangle A. And then let's find out what is the area of rectangle B. The height is 40, the width is 50, so you're just going to take a product, which gives you 2,000 meters. And then the total distance is obviously the sum of the two, which is 600 plus 2,000, and that gives you 2,600 meters. So by finding out the area under the graph for this p time graph, you can actually find out what is the distance traveled by the object.